You know, it's one of those things we absolutely rely on every single day, but never really think about. There's this massive, invisible system right under our feet, handling something we all, well, produce. So let's dive into this hidden world and find out what really happens after that water disappears down the drain.
I mean, seriously, have you ever actually wondered? You push a handle, the water swirls, and poof, it's gone. But where is gone exactly? Well, let me tell you, the answer is way more interesting and a lot more complex than you might think. It's actually a marvel of modern engineering.
Just get a load of the scale of this place. This isn't some small-time operation. We're talking about a facility practically the size of a small city, and it has just one job: cleaning our water. It's this huge, intricate system designed to undo the mess we make 24/7.
So the process we're digging into here is called sewage treatment. Now that's a specific, really important kind of wastewater treatment. Its entire mission? To get all the nasty stuff out of our sewage so we don't pollute our rivers and lakes. It's basically an essential shield protecting our health and the environment from some pretty serious disasters.
Okay, so what exactly are we talking about when we say sewage? Well, it's pretty much all the wastewater from our homes, from our businesses. And in a lot of cities that have what they call a combined sewer system, it also includes all the rain runoff from the streets. Yep, it all gets mixed together and sent on one big journey.
All right, to really get a handle on how this whole thing works, we are going to follow a single drop of water on its incredible adventure through a typical treatment plant. It's a total transformation, happening in several different stages, and each stage has a very specific cleaning job to do.
Okay, so here's the whole shebang, the full roadmap from start to finish. I know, it looks like a super complicated flowchart, but trust me, it breaks down into a few key phases. We're going to walk through each one, step by step, so it all makes sense.
And our journey starts right here, with primary treatment. You can think of this stage like the bouncer at a nightclub. Its job is to get rid of all the big, obvious stuff that just doesn't belong there.
This whole stage is purely physical. No chemicals, no biology, just physics. First, all the incoming water passes through these giant metal rakes called coarse screens that catch things like rags, sticks, you name it. Then it flows into grit chambers, which just slow the water down enough for heavy stuff like sand and gravel to sink. And finally, in these massive tanks called primary clarifiers, the water just sits for a while. This lets the heavy solids drift to the bottom and any grease or oil float to the top. And believe it or not, this simple process alone gets rid of about half of the junk floating in the water.
So what happens to all that gunk that gets separated out? Well, that becomes something called sewage sludge. This stuff is a really important byproduct, and it gets pumped away to be treated all on its own. And here's the cool part. Sometimes, after a whole lot more processing, it can actually be turned into a useful fertilizer. Okay, with all the big stuff gone, our drop of water is ready for the next step. It flows into stage 2, secondary treatment. Now, if the first stage was all about physics, this is all about biology. This is where things get really interesting. Yup, you heard that right. The star of this show isn't a filter or a screen, it's life itself. This is the biological phase. We basically unleash a highly specialized army of trillions of helpful microorganisms whose only job is to eat the dissolved pollutants that are still in the water. And this right here, this is an aeration tank. It's the heart of the whole secondary treatment process. You see all those bubbles? They're pumping oxygen into the water to create the perfect 5-star resort for good bacteria to thrive. And these bacteria go on an absolute feeding frenzy, breaking down all the remaining gunk into harmless stuff like carbon dioxide and, well, more good bacteria.
So, after our little microbe friends have had their fill and have settled out, the liquid that flows out is now called effluent. It's way, way cleaner than before, but for some, the journey isn't quite over yet.
For a lot of treatment plants, especially ones that release water back into really sensitive environments, the process doesn't just stop there. There's one more cleaning phase, called tertiary treatment. You can think of this as the final polishing stage, designed to get the water as pristine as possible. So what's the point of this extra step? It's all about targeting very specific pollutants that the microbes in the last stage couldn't get. The main targets are nutrients, specifically nitrogen and phosphorus. See, if you dump those into a river, it's like throwing a huge bag of fertilizer into a pond. You get these massive, gross algae blooms that suck all the oxygen from the water, killing fish and just wrecking the ecosystem. This stage is all about preventing that from happening. We are at the very last gate before our drop of water gets its freedom: disinfection. because no matter how good the previous stages were, there could still be some invisible, disease-causing pathogens hanging around. This final step is all about making sure they're completely neutralized.
So, how do they do it? Well, there are a few options on the menu. The old classic is chlorination. It's cheap, it works, but it can sometimes create some unwanted byproducts. A more modern way is using UV light, which basically zaps the germs with intense light. No chemicals needed. And then you've got the heavy hitter, ozone. It's super powerful, but also the most expensive.
Now, I have to be really clear about something. The whole process we just walked through, this big, complex plant, that's just one way of doing things. There's no single, one-size-fits-all blueprint for cleaning the world's water.
On the one hand, you have a super high-tech plant like we've been talking about. It's efficient, but it's also expensive and uses a ton of energy. But on the other hand, you have something that looks more like a park, a constructed wetland. It uses natural processes with plants and soil doing the heavy lifting. It's a lower-tech, lower-energy solution. The right choice is always about what a community really needs and what it can support.
And this idea of different solutions brings us to a much bigger and honestly a pretty sobering reality. Access to this kind of critical infrastructure is not universal. Not even close. There's a massive, massive divide across the globe.
Just let this number sink in for a second. 52%. That's the percentage of the world's sewage that gets any form of treatment. That means almost half of all the sewage we produce as a species is just dumped, raw, straight into our rivers, lakes, and oceans.
And if you think that global number is bad, look at how it breaks down. In high-income countries, we treat about 74% of our sewage. Not perfect, but, not terrible. In developing countries, that number drops to just 4.2%. I'll say it again, 4.2. That's a staggering difference with huge consequences for global health.
So what's the big takeaway here? The journey of our water is, without a doubt, a triumph of engineering. But it's a triumph that billions of people around the world don't have access to. And bridging that gap is one of the most important environmental and public health challenges we face today. It really makes you think, doesn't it? When you truly understand the incredible amount of science, energy, and infrastructure that goes into returning our water safely to the environment, it kind of changes how you look at that simple glass of clean water from your tap. What is that truly worth?